So let's take a moment to go back in time to grade 10 and just make sure we know the three main trig functions. So trig function number one, the sine function. Okay, and you'll see that the sine function has a period of 360, amplitude of 1, and it starts by kind of going up, down, down, up, and we call these 2 points like here and here the turning points. Okay, so that is the sine graph, period of 360. The cos graph is going to be this one over here. Cos graph looks quite similar to the sine graph, except it looks like it goes down first if you're starting at 0, and then down again, and then up, and then up. And what you notice in both these graphs is you kind of draw them in quarters. They have sort of like every 90 degrees, or every, in the case of the default one, they kind of have the shape repeated in a different way. And the period is 360, amplitude is 1. And then the tan graph is the last one. Now the tan graph looks a bit different. So let's zoom in so that we can really give it our full attention. Let's zoom in a little bit. And what we notice with the tan graph is that it's a completely different shape. And it has these funny dotted lines here. Well, let me change that. What are these dotted lines over here? What are they for? Who would like to tell me? Who feels like they know what those funny yellow lines are? They are asymptotes. Yes, Morgan. Yes, Naomi. These are asymptotes. Lines that you get closer and closer to, but never get there. And what you notice is that the sine and cos graph don't have asymptotes. So the tan is a little bit special like that. The other thing is when we draw the tan graph, we don't normally draw it in quarters, we draw it in halves. So like oh, that's too big. We draw it like that half, and then that half, or that half, and that half. So the way we actually draw it, because of this discontinuity, is a little bit different. I kind of say we draw it in halves and not in quarters. What else is different about the tan graph when compared to the sine and cos graph? Who can tell me in the chat? What's different about this tan graph compared to the sine and cos graph? Okay, yes. Tabiso, you've nailed it. The period is 180, whereas the period in the sine and cos graph is 360. And what that means visually is that for a whole cycle of the tan graph to happen, it only takes 180 degrees. So let's say between here and here, you can see that between the two asymptotes is 180. It's one full cycle of the tan graph. Whereas if you look at the cos graph, a full cycle of the cos graph fits into 360. Okay, so those are the important differences, and tan definitely has its own little world going on. Seratimwa, let's unmute you for a question. What can I do for you? Unmute yourself first. There's a little button at the bottom, and we're asking you to unmute. If you just hit the little unmute button.
Why the graph of
yes.
Why the graph of tangent does not have the amplitude?
Oh, good question. Good question. So the amplitude is how high or low the graph goes. So in the sine and the cos graph, you'll see that this is called the position of rest, from which it goes above or below. And you'll notice that the sine graph only goes up by 1 or it goes down by 1. And the same with the cos graph, it goes up by 1 or it goes down by 1. With the tan graph, it goes up and goes up forever and gets closer and closer and closer. You can get the tan of any number. And so the reason there's no amplitude is that there is no restriction on it going upwards. But what we normally say is that instead of it being the amplitude, it's the value the graph takes on at 45 degrees. And so we kind of say, to see how steep the tan graph, we always look at the tan of 45, and in a normal tan graph, it's 1. But the amplitude doesn't make sense in the same way for the tan graph because it doesn't get restricted in terms of going up or down. That is such a good question. Did that help a little bit, Siratiwa?
Yes, sir.
Pleasure. Thank you so much. Okay, now, one more thing. In the last lessons we did on trig graphs, I told you about how to use your calculator, and we used what's called the table function. If you know how to use the table function in your calculator, just say yes in the chat. If you don't know how to use the table function on your calculator, say no. And I just want to make sure I get a feel for what the group is like today. If I need to show that again, maybe today or in the next lesson. The table function helps you draw trig graphs. Okay. So there's a couple of us who need to see the table function. So I'll see if I can bring it up later today. Otherwise, I'll bring it up in the next lesson if I can't get it working today. And all the table function does is you go into like a table, and in fact, I'll show it to you. It's easier that way. Okay, thank you for your input in the chat. Now, the other thing is when we talk about the basic trig graphs, they are what we call transformations. And so if we look at this screen, there's a lot going on, but I just want to draw your attention to a couple of things. There is the A thing in front. Let me see if I can get the highlighter to work. Nope. There we go. There's the A, and what that changes is the amplitude of the graph. Then what we have is the Q value. So let me actually bring this out. And what this does, the Q value shifts it up or down. And so those are the more common ones. Then we also have this plus P over here. And I want to know in the chat, what does the plus P do to your trig function? These are transformations of the basic trig graphs. What does the plus P, or what does that have to do with? Pop your answer in the chat. Okay, keep them coming. Can you still see the screen, Level?
Yes, we can still see it, Mr.
Okay.
Yes.
Cool. So the P graph shifts the graph, the P value shifts the graph left or right, and it's what we call the horizontal shift. And then the last thing we need to be aware of before we go forward today is this, what we call the K value over here. Now I know it's quite a lot of detail, so we're going to look at specifics, but what is the K value going to influence in my trig functions? What do you think the K value affects? Now previously we spoke about the basic trig graphs, but now we're going to talk about how we can change letters and variables and things like that. Yes, so K affects the period of the graph. And when we say the period, we talk about how long it takes to do one complete cycle. Yes. Now, there's a magic formula up here that I want us to look at. It says the period is going to be 360 divided by K. And then on this side, it says period equals 180 over K. Who thinks they can explain to me why there are two different formulas for the period? If we're going to work out the period and we're going to change it involving K, why are there two different formulas? You can pop your hand up if you want to give an audio thing, if it's quicker. Otherwise, pop it in the chat. Why are there two different formulas for the kind of the period of a trig graph and this k value? Aha, Morgan has suggested, and so is Tegavatzel, that the sine and cos graph have a period of 360, whereas the tan graph has a period of 180. So if you have a, if you're trying to work out the new period of a changed graph, you should use, for the sine and cos graph, you use 360 divided by k, and for the tan graph, you use 180 divided by k. So let me give you an example. If I say to you that y equals sine 2x is my new trig function, I want to know what is the period of this graph sine 2x. Tell me in the chat what the period of sine 2x is. And I thought I saw someone's hand go up, but I'll wait a bit. Yeah, so the new period of this sine graph, the new period is going to be 360 divided by k, or 360 divided by 2, and it's going to be 180 degrees. Fantastic. Now, what if I said to you, there is a new trig function, and it is tan 3x. What is the new period of the graph y equals tan 3x? What's the period going to be of that graph? So we know the formula says 180 divided by k, so we go 180 divided by 3. And the new period is going to be 60 degrees. Now, what that means is that a whole tan graph is going to fit in 60 degrees, right? So if we imagine we were drawing this graph, we would know that a whole tan graph will fit in 60 degrees. And that's what it means to change the period of the graph. Okay, give me a thumbs up if you feel like you understand roughly what A, K, P, and Q do, and you can change the period of a trig graph using this example that we just showed you. Okay, now so let's go and do some multiple choice questions based around this idea of taking a trig graph and transforming it. I'll come back to some axes later on. Okay. Let's do this one. What is the period of the graph y equals sine a half x? What is the period of the graph y equals sine a half x? And you can put your option A, B, C, D, or E. So the normal period of the sine graph is 360. And this number in front here is a half. Now, what does that do? It feels like I need to divide it by a half. And that I can use my calculator, or I can use fractions. I should get 720. And so the correct option is going to be 720. Well done, everyone. That wasn't so bad. Okay, now let's pause for a second and see if everybody's happy. Give me a thumbs up if you understand how I got 720 for the period of the sine graph. Give me a thumbs down if you feel like you don't understand. And if you don't understand, I encourage you to put your hand up to ask a question or put a question in the chat. Okay. Cool. So what we're doing, Onati, in this one is the normal period of the sine graph is 360. And then this number in front of the x, we always divide by that number to get the new period. And so I went 360 divided by a half to get 720. Okay. Let's do another one kind of like this. What is the period of this graph? What is the period of this trig graph that is not a simple trig graph? It is a trig graph that has had some changes happen to it. So you have to ask yourself, which one do I need to look at? Do I need to look at this 2 over here? Or do I need to think about this 3 over here? And this is where we need to know what effect these have. So I see a lot of love coming in for E. Now I need to work out the answer myself. Well, let's start by this. I think the 2 doesn't have anything to do with the period. The 2 affects the amplitude. It affects how the graph gets stretched up or down. So the 2 will make it like go further up and further down, but I'm not interested in that. What I'm interested in is this 3. So I start by going, what is the normal period of the cos graph? It's 360. I now divide by the number in front of theta. This is like the K value I spoke about earlier. Divide by 3, and the new period of the graph is going to be 120 degrees. So this graph's changes are going to be that not only does a whole cos graph fit into 120. So let's just say like that's a whole cos graph is going to fit into 120 degrees. But not only that, this one has been stretched upwards because of the 2. Now I'm doing stuff that is beyond the question. I'm just trying to fill in the blanks. Like it's also going to have been stretched like this. And that would be the effect together. But the question only asked about the period. And so the answer would be 120. Okay. Thumbs up if you're feeling good. Thumbs up if you're feeling like, slow down, Mr. S. Slow down. Okay. Let us try something a little more exciting. So I am giving you a graph below, and you have to tell me which formula goes with which graph. Which formula goes with which graph?
Mr. S,
Yeah.
can you please explain the answer for the previous question again?
I can. Let me just zoom in a little bit so I can see it. So everyone keep putting your votes in there. So in the previous question, we had this function that looks like this, and they asked us what is the period of this trig function. So this is the previous one. The only number that mattered was this number. So all I needed to do was say, what's the normal period of the cos graph? It's 360, and divide by the number in front of the theta, and then you would get 120 degrees. The drawing I did, that was just extra me explaining. It wasn't part of the question because the question said period. They want the period of the graph. Now, what's different in this question is I'm given the graph. I need to work out what the period is, and I guess connect it to this. I think the period of this graph is 120. And from the shape, it looks to me like it's a cos graph because it's going down, down, up, up. So I'm going to eliminate the sine graphs. I don't know about none of the above. So I have to decide between these two. But this graph over here hasn't had the period changed because there's nothing in front of the theta. And so I would say that the period of that graph is 360, which is not what I want. I think the answer is B, because B would have a period of 120 and have the shape of a cos graph. And so the correct answer is going to be B. Okay, so we can ask that question in a couple of ways. Okay. Let's look at this next one. Now again, please let me know if I'm going too fast, because the idea is that I'm giving you interpretation questions as opposed to just drawing stuff. So it says, in fact, for bonus points, before we get going, what are the two changes that have been made to this graph? It used to be y equals sine x, a nice old grade 10 trig graph, and then it got the grade 11 treatment. What are the two changes that have happened to this graph before we answer the question? And if you want to be an audio person, that would be fantastic. If not, chat is good too. Tell me what the grade 11 treatment was in this case. What change has been made to this graph compared to the normal vanilla sine x graph? You're going to think back to the beginning of the lesson. What did this thing do at the beginning of the lesson? What did this thing do? Okay, so we know the period has been changed because we've been kind of doing that type of question for a while now. This is almost like the K value. What is this plus 30 doing? Mesh has put some good stuff in there. Neo has got some good stuff. Tandeka. The plus 30 is a shift or horizontal shift. And in this case, it's a left shift by 30 degrees. So the horizontal shifts always work the other way around. So this is a left shift of 30. And the period is changed with the 2. And we say the period has been halved. So really what happened is the period was halved and it shifted 30 degrees to the left. Now that's bonus work, but I just want to keep building up your vocabulary. Okay, now over to you guys. Which of these 5 graphs has the same period as the original graph at the top here? So you've got to decide, and I'll give you some time to think about that, because it's a good question. Which one do we think? So I suppose we should ask ourselves, what is the period of this graph? And it's going to be 360 divided by 2 is 180. So the period of this graph is 180. Which of these 5 also has a period of 180? Well, maybe there's a couple of answers, because this is a plain old tan graph, which is 180 degrees its period. This one hasn't had a period change, so that's going to be 360. This one hasn't had a period change, so it's 360. This one is going to be 360 because it's a normal cos graph. And this one is going to be 360 divided by 3, which is 120. Now, of these 5, which one matches the period of the first one? That was a good question. Love a good question. So the only one that matches is the 180. Because this is a plain old tan graph with a period of 180. And I'm looking at the chat and I'm seeing lots of A's, which is great news. Okay, thumbs up if you feel like you're following along. Thumbs down if you're feeling a bit confused. We're going to do one more, then we're going to have a break. Okay. Okay, last one before the break. Last question before the break. We are going to talk about something called the range. What is the range of this trig function? And first of all, before we even get to that, what is this 1 doing over here? What effect does the 1 plus sine x have on this graph? Amesh, I'll have another go now while students are working on this question here. So in this question, Mesh, first of all, I had to look at the original graph and I had to ask myself, what is the period of this graph? And the important number is this 2. Now, the normal period of the sine graph is 360. But because of the 2 over here, the period of this sine graph is 180. And now I'm looking for a period of these graphs that is the same as the period of the sine graph originally, which is 180. And the only one that has a period of 180 is the tan graph. These other ones haven't had a period change, and so they are all their normal period, 360. And then this one has had a period change, but it's changed from 360 to 120, which doesn't match the 180 that I wanted. Okay, now what do we think the 1 does? I think the 1 doesn't actually increase the amplitude there. That 1 is the same as writing sine x plus 1. So that's exactly the same thing. It's just written in a bit of a wonky way. So what do we think that plus 1 does? What do we feel like that plus 1 does? Pleasure mesh, pleasure mesh. I think it shifts the graph up. It goes up by 1 unit. So then, if I think of the normal sine graph, the normal sine graph goes between 1 and minus 1. But everything has been shifted up by 1 unit. Let me use a different color. So now the range, or not the range, sorry. Well, it is the range, I suppose, yeah. How high or low it goes is not going to be between minus 1 and 1. What's it going to be between? So normally it's between minus 1 and 1, but everything has been shifted up by 1 unit because of the blue plus 1. So what is the range going to be now? I think the lowest value is going to be a 0. And the highest value is going to be a 2. Now, which of these 5 options corresponds to 0 to 2 for the y values? So it's not this, and it's not this, because that's a normal sine graph. It's not that, and it's not that. The answer is going to be that one, between 0 and 2. Okay, so what have we done in this first half? We've looked at the basic trig graphs, and we've looked at how we can interpret the 4 basic transformations of a trig graph with a real focus on how do we work out the period of graphs when they change. But I think you've done really well, and it's time for a break. So I want you on your feet, and we are going to have some quality exercise time just to get our brains a break. So on your feet, turn those cameras on, and let's do this.
Please turn on your cameras, guys.
All
Let's
right.
see your lovely faces.
I want you to stretch up. You can have your feet on the ground. It's fine to stretch up like you're going to touch the sky. Feel your stomach is nice and tight, and you just face up and you stretch out your body. And while you're doing this, I want your eyes to look at somewhere far away so that we give our eyes a break. We've been staring at a screen, and we want to make sure our eyes get a chance to stare off into the distance. So if you've got a nice view, you can do that. Okay. And then let's stretch our necks a little bit. The left. And to the opposite side. Okay, then let's shake out our arms, get some blood flow, shake out the other arm. Pretend you're a licorice, all sorts, or something that's bendy. Shake out your legs. See if you can shake them out nicely. And then let's do some rotation. So kind of arms out like this and a slow turn to start with. And as you feel yourself loosening up, you can go further around. Okay, and then let's just roll the shoulders back. Do 5 rolls back. 1, 2, 5, and 5 rolls forward. 2, 5, and then shake it out again. Okay, then let's do some heart rate raising activities. Let's just do 15 jumping jacks. Make sure the space around you is clear so you don't whack anyone. And let's go in 3, 2, 1, 2, 4, 5, 8, 9, 10, 5 more. 4, 5, and that's it. Well done. I hope that your body is enjoying that break. What have I done? Screen share. There we go. Here is your brain break for today. What is a giraffe equal to? What is a giraffe equal to? So a monkey, what's a monkey? Maybe we should start with a monkey first. Yeah, so we sit a lot, so it's important that we stretch out. And then as you stretch, you start to realize, oh, that felt good. And then that's your body's way of saying, please stretch some more. So the monkey is 4. The question is, what is the giraffe? Maseko, Temi has something there. I want to see if a few more people can confirm. So I'm guessing that this side is 8. So a giraffe plus 3 divided by 2. So I'm thinking we're going to pull an algebra trick and we're going to move this 2 to the other side. And then I've got a giraffe plus 3, because you know if you times both sides by 2, we can get rid of that 2. So I think 2 times 2 is 4 times 4 is 16. So a giraffe plus 3, I shouldn't even try and draw a giraffe, but anyway, equals 16. So what is my giraffe going to be? Okay, so something plus 3 is 16. That something has to be smaller. And so I think that something is going to be 13. And so a giraffe is equal to 13. Well done, Tandeka, and Neo, and Mesh. There we go.
Well done, guys.
Well done. Okay, cool. I think it's time to return to our lesson. So let's go back. These multiple choice questions are helping us learn a lot today. So now, here is your question. It says, f of x is equal to the sine graph minus a half. Tell me what the minus a half does to the sine graph. What does the minus a half do to the sine graph? I thought I saw a question. Did I see a hand?
Yes, there's a hand from Vivian.
Do you want to unmute Vivian? It's not a period change because this number is actually at the end all by itself. So if it was in front of the x, it would be a period change. But because it's just hanging out by itself, it's actually the q value, and it shifts the sine graph down by a half. But now, if I look at this question, Vivian, are you with me? Hi, Vivian, can you hear me? Hello. Maybe we've had some technical issues. Now, what's happening here is that they're saying the distance between the f and the g graph. What is this one telling us? This one is telling us that the g graph, or the g of x, is 1 unit above the f graph. So you have to use the clue from here and the information from here to try and figure out which of these 5 options goes with this. So remember, they're telling you what f is. So they've told you the equation of f. But they want to know what the equation of g is, and they tell you something about g's relationship to f. See if you can figure out which one it goes with. And then if there's a question, please put your hand up and I'll interact with you. There might be some good questions here. So remember, you've got f and you want to get to g. How would you get to g? How would you take this and make it into the form of the g graph? So g of x is equal to just whatever f of x is. So that's what f of x was, but there's some change. And I think all that I need to do is add a 1. Because it's 1 unit above. And that would shift this graph up by 1 unit. But then what's the equation going to be? It's still going to be a sine of x, but instead of minus half, it's going to be plus a half. Because minus a half plus 1 together gives you positive a half. Is there something that matches that over there? I think D is going to be the correct answer. Now that was a harder one. That was quite a bit harder. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow that, because I'm pushing you a little bit now.
Mr. Ayers?
Yeah.
Vivian's question was, what's the difference between the range and the amplitude?
Aha. So the amplitude is just how much above or below the position of rest you go. So the amplitude is normally half the range. So if you want to find the amplitude, you normally go the biggest value, the max, minus the min, and just divide by 2. And so the amplitude is generally half the length of the range because it's how much above or below the position of rest goes. That's a very good question, Vivian. To show you the difference, say, for example, we have a sine graph that looks like normal. So it would go up to 1 and down to -1. Now, in this case, the range is going to be between -1 and 1, but the amplitude will be 1. However, if we change the amplitude to 2, what's then going to happen is that the graph would go up all the way up to 2 and then down again and up like that. And so in that green graph, the amplitude is 2, but the range is between -2 and 2. And so you can see that like the distance, the range is going to be 4 units big for the green one, but you divide it by 2 and you get 2 the amplitude. Vivian, just let me know if that helped a little bit. If that made sense to you. Okay. Cool. So don't be afraid to ask questions as we go, because I think it's helpful to keep learning. Now, I'm not going to go into trig, or maybe I should. Let me finish with this today. But we're going to carry on with this in the next lesson. So one of the things you need to be able to do in trig graphs is solve trig equations. And trig equations are a little bit special because there isn't just one solution. So let me give you an example of this. This very first question here, it says sine of x equals 0.2. Find the value of x that makes this true in the domain 0 to 360. And what I want to show you is the sine graph that we are used to goes up to 1, down to 0, and let's say down like this, and then up like this. So let's say that's a 1. So 1, this is a -1, and this is, say, 90, 270, 360. Now, if I want to solve this equation, where is the sine of x equals 0.2? I want to suggest that the graph of y equals 0.2 looks like this. Give me a thumbs up if you understand how I took the graph of sine x and the graph of 0.2 and made this graph to show you the story. Say, let me know in the chat if taking this equation that I want to solve and giving you a story that's based on a graph, if that made sense to you, give me a thumbs up, give me a thumbs down if it doesn't make sense. Okay, I think I might have lost a few of you. Okay, let me slow down and I'll explain in a bit more detail. On a most basic level, when we are solving trig equations have a trig ratio and a number. And what do we normally do with a trig? What do we normally do with an equation? We solve the equation for the value of x that makes the statement true. So I am looking for a value of x that when I put sine of that value, I get 0.2. So that's what I'm looking for. Give me a thumbs up if you understand that I'm looking for a value of x. To solve this equation, I'm looking for a value of x that when I say the sine of this value, I get 0.2. So give me a thumbs up if you understand that statement. Okay, now, if we go back to earlier in this section, we spoke about intersection points. If you want to find where two graphs intersect each other, what do we normally do? Pretend I have two graphs. The one graph is y equals 0.2. The other graph is y equals sine x. What do we do? What do we need to do to find the intersection points? We did this in previous things. How do we find the intersection points of two graphs? Don't we normally just make them equal to each other? So what I want to suggest is it's a simultaneous equation, yes. And don't we just make the two graphs equal to each other? And that will give us the intersection points. Now, if we look at the graph of y equals sine x. That's the blue graph. The red graph is just the constant function y equals 0.2. And I want to suggest that the one answer is going to be here and the other answer is going to be there. Now, let's take a guess. I think the only answers to this equation are going to be between 0 and 180. Why do I think there are only going to be answers between 0 and 180 and not between 180 and 360? Does anybody, like, why do we think there are only going to be answers around there? I think it's because the graph shows us that they can only cut off, the two things can only meet each other at that point. So let's take a little guess. I'm going to guess that the value here is 30 degrees. I want you to put in your calculator the sine of 30 and see what you get. Maybe I'm right, maybe I'm wrong. Who knows? We're going to find out now. What do you get for the sine of 30? So Tegelvatso says I get the sine of 30 is 0.5. So does Temi. So does Mesh. Is 30 degrees going to be an answer to my original equation? Is it going to be an answer? I took a guess. Is it going to be the correct answer? No. The only way it would have been correct is if I got 0.2. And so what I need to do is I need to have a way of exactly finding out what that value is. Now, we're going to run out of time today, so I'm going to continue with this in the next lesson. But what we do is we use the inverse function on our calculator. So I want you to put into your calculator shift sine, and you should get sine of -1 or inverse sine. And I want you to put 0.2, and then I want you to give me a value for that. Okay, so the answers that I'm seeing in the chat are 11.54 or 11.5 if we round off. And so the answer, the one answer to this question is going to be 11.54. And just check in your calculator. If you type the sine of 11.54, do you get something very close to 0.2? So we're just going to check our work. Say, if I go the sine of 11.54, do I get something close to 0.2? Okay, good news. So one answer that we figured out is that x is 11.54, but this drawing tells me there's another answer in this restriction. Who knows how we're going to work out this other answer? Does anybody have an idea of how we're going to work out this other answer? I will tell you in a second because we're running out of time today, but does anybody want to guess how we get this other answer? So all we need to do to get this other answer is go, and this has to do with the cost diagram and trig equations, we just go 180 minus 11.54. And what do you get for 180 minus 11.54? So we get 168.46. Now, to see if this truly is the correct answer, I want you to put in your calculator the sine of 168.46. And what do you get? Do you get, if I'm telling you the truth, I should get very close to 0.2. Aha, I'm seeing good things in the chat. So what have we learned at the end of this lesson today? If we're going to deal with trig graphs, we have to learn how to solve trig equations. And when we have trig equations, there can often be more than one answer. And that's because these graphs repeated themselves. All we learned about today is how to use the inverse trig function, where we give our calculator the number that we've got and say, go backwards and give me the angle that will satisfy that equation. But there was more than one answer, and we need to talk about a method we can use that can get us all the answers that we need. And that's what I'm going to carry on with in the next lesson. Okay, but the main focus today was just to be playing around with the graphs, and so I'm going to call it at that point.